Okay, this is lesson 19, linear functions, graphing linear functions, standard form, ax plus by equals c. We're going to have a slope, average rate of change, and linear models. First thing is that a function is in the form, is normally we're used to seeing y equals to, and then the equation, but now we're going to use f of x, where in any linear equation you're going to have a domain where the line's going to go from negative infinity to infinity. In other words, if you have a line on a graph like this, the line's going to go for forever to infinity. And so basically our domain would be what we would call all real numbers. Okay, here we have a graph. We want to graph this function, negative 2x plus 6, and we want to use what we call the xy intercept method. Basically, all we do here is just, first you substitute 0 in for x and solve for y, and then you're going to substitute 0 in for y and then solve for x. So first we're going to put here, this would be the same thing as if we were to say y equals to negative 2x plus 6. It's like we're cutting that 0, that x out, and we're going to put 0 in there. Well, negative 2 times 0, that's 0. So we're going to go y equals to 6. And so our first coordinate point here, our y-intercept, would be at 0, 6. So if we were to graph this on the coordinate plane, here's x, here's y. X is 0, y is 1, 2, 3, 4, 5, 6. Alright, so that's our y-intercept. Now we're going to set y equal to 0 and solve for x. So this would be 0 equals to negative 2x plus 6, and now we solve for x. And we apply minus 6. We get negative 6 equals to negative 2x. Divide by negative 2. We get x equals to 3. So in that case, since y was 0 and x is 3, this would be 3, 0. And so if we were to graph that, then our line would look something like this. Okay? And so that's known as the xy intercept method. Alright, any questions with that? Alright, what you've been used to before was basically using the table of values method. You've also used the slope intercept method. Well, this is the xy intercept method. Alright, any questions with that? Okay, and there's what it looks like on the graph. Alright? Notice the domain is negative infinity to infinity, where this graph, if we're to, this graph basically goes on forever. In the x direction, goes forever in the y direction. So, if you're looking at each value for x, it continues on infinity in the negative direction. Here's x. And so x would continue to infinity in the positive direction. And so that's why our domain is negative infinity to infinity, or infinity in the negative direction. direction to infinity in the positive direction. And notice these open parentheses for infinity, the parentheses are always open because you can always go towards infinity, but you're never going to get to infinity. So that's why infinity is always open, whether it's positive or negative infinity. Okay, any questions with that? Another thing is linear equations are always going to have a domain negative infinity to infinity. Okay? Alright. Okay, we want to graph f of x is equal to negative 3. Give the domain and range. Now here, if you look, this would be the same thing as if we were to say y were equal to negative 3. So if we were to work this using a table of values, the negative 3, would that go under the x or the y? Travis?
Y.
That's right, because y equals negative 3. So y is going to be negative 3 forever, right? And for x, you can put anything. Negative 3, 0, 2, let's say. And so if you were to graph that, okay, then here you have, here's 1, 2, here's negative 3, 1, 2, here's positive 3, 1, 2, here's 3, and 1, 2, here's negative 3. Negative 3, right? We use red. 0, x is 0, y is negative 3, and then 2, negative 3. So you can see here that it's a f of x equals to negative 3 is a horizontal line that goes through the y-axis at negative 3. Okay? So you want to look at this in terms of, which axis is it going through? It's going through at negative 3. Going through the y-axis at negative 3. So you don't necessarily have to do, show the table of values here, but it may be a help for you to do that. Okay? Alright, questions with that? Alright. This up a little bit. And so that's what it's going to look like. Here's x. Last one was f of x equals negative 3. Well, this one is x equals to negative 3. So in this table of values, see, because the last one, f of x, it could have been f of x equals negative 3, so you could have rewritten it as y equals negative 3. But here, this is x equals to negative 3. So now, x is negative 3 forever. And you can put anything in here for y, like negative 3, 0, 5. Well, here's negative 3, negative 3. And then here's negative x is negative 3, y is 0. And then here's 1, 2, 3, 4, 5, negative 3, 5. So you can see that that's a vertical line. And so this goes through the x-axis at negative 3. Okay, so that's your vertical line. Okay, now here the domain is only a single point at negative 3. Does not move to the left. It does not move to the left. It does not move to the right. It's just negative 3 for your domain. Okay? And so in that case, that would be closed at negative 3. Okay? Questions with that? Alright. Whereas here, now they're talking about, see, here's the domain. Now they use curly brackets, but for a closed, these are closed, so I don't know why I guess they're looking at it in terms of set notation, but in reality it should be closed bracket like that. I'm surprised they actually used the curly brackets on that one, but you're probably looking at it in terms of a set. The range are all the y values. So that's going to go on from negative infinity to infinity. So you have to look at the range like it's up and down. So it helps to write, you know, your lines up and down, and then write, you know, range on that, and then see, okay, where's my range at from there, and then, you know, subtract your lines and so on from there for your range, if you need to. Okay, so this one actually shows the domain and range. All right. Here we want to graph. You want to find the intercepts. Okay, so we're going to use the xy intercept method to find the our intercepts. So you're going to substitute for 0, solve for y, and then you're going to solve for y and solve for x. All right, so go ahead and try this. All right, find the intercepts to this line. Okay, 4x minus 5y equals 0. Okay, so if you substitute 0 in for x, you get 4 times 0 is 0, so you just drop that, you get negative 5y equals 0. So you divide negative 5 into 0 and you get y equals 0. Well, what happens, so this would be your, it's just going through at the origin. Okay, so we're right here at 0, 0. Well, what happens when you substitute 0 in for y? Here's 4x minus 5 times 0. Okay, we get 4x equals 0, right? Divide by 4, and we get x equals 0. So basically all we have is just 0, 0. Okay? So we've got this line here that's going through something like this, right? But we don't know exactly where it is. Well, we need another point. So what we do here is we're going to solve for y. Okay, so we've got here 4x minus 5y equal to 0. Now you could either subtract 4x or you could add 5y. And I like to go ahead and apply 5 plus 5y to both sides. And so when we do that, we're going to get 4x equals to 5y, and then divide by 5. And so we get y, or we get 4 over 5x equals to y. All right. Now, you have this table of values. We need another point. Well, in this case, since y equals to 4 over 5x, we want a number where we can get rid of that denominator. Okay, for x, so that we can substitute that in and eliminate the denominator. We don't have to mess with a fraction. So what number could we use? here's 4 over 5. Alright. We want something in there, right, that we can cancel that denominator out. What can we use? 5, right. We can put 5 in there, and then the 5's cancel. And what's left? Y equals what? 4. Well, now, careful now, because the 5, it's like we cut that x out, right, and we substitute 5. So it's just 4, right? So now x is 1, 2, 3, 4, 5, and y is 1, 2, 3, 4. Okay? Now another thing you could have done at this point is you could have used slope-intercept method, where you could have said y equals to 4 over 5x plus 0, where 0 is the y-intercept, and then you would just go up 4 and across 5. And then just draw your line from there. So you can use it either way. Okay? Now my question to you guys is, which one do you prefer? You prefer to use the slope-intercept method or just substitute another point? Excuse me. Or does it really matter? Talk to me, guys. Alright, well anyways, you could use either method. Alright. And so this is what our point looks like on the graph. Okay. Okay, the slope is basically rise over the run, where you subtract the y values over the x values. y2 minus y1 over x2 minus x1. This triangle is basically delta y, or the difference in y, over the difference in x. The slope of a vertical line is undefined. So if the slope is positive, and we use m for slope, then basically your line slopes up. If your slope is negative, then it's going to slope downward. Okay? So you want to use that to kind of help you to check that, make sure that you have the right slope there. All right, and so that's why here the slope is a vertical line, and what they mean is vertical line like that. If you had here, let's say this was 3. Let's say this point here is 3. And this is 3, 0. And let's say this point here is 3, negative 3. Okay? This is x1, y1, and x2, y2. So that would be y2 minus y1 over x2 minus x1 would be y2 is a negative 3 minus 0 is y1 over x2 is 3, x1 is also 3, so you end up with negative 3 over 0. Well, anytime 0 is in the denominator, that's undefined. Okay, 0 in the denominator is undefined. when you have 0 in the numerator, then that's 0. Okay? Questions with that? Alright. So, find the slope of the line given these 2 points. So you want to label it x1, y1, x2, y2. And you're going to be using slope of 2 points equation, y2 minus y1 over x2 minus x1. Alright, so go ahead and find the slope given those 2 points. Alright, try that. Okay, you should have gotten a negative 11 over 6. Alright, questions with that? Now notice here that we have 2, x2 is 2, and then we have a minus here, and then we have a negative 4. This minus here is for the equation. This minus here is for the x1. So you have to list them both. Okay, so you want to be careful. And list both negatives. Okay? Alright, questions with that? Alright, graph f of x equals to negative 3. Now again, this is like saying y equals to negative 3. Now we did this one already, so we're not going to, it's just a vertical line. Okay. Let's say we're given an equation here, and we want to find the slope. Basically, we're using the slope of 2 points equation, y equals mx plus b, where the slope is the coefficient of x. Okay, so basically, what we want to do here is solve for y first. That's the first step. Okay, so we applied minus 4x to both sides. And then we got 3y equals negative 4x plus 12, and then divide by 3, divide by 3, divide by 3. And get y equals to negative 4 over 3x, 3 goes into 12, and that's 4 times. And so now our slope is the coefficient of x. Negative 4 over 3. It's not negative 4 over 3x, it's not that. And it's not the equation. Okay? It's not the equation. It's only the coefficient of x. And that's all. Alright? So, when you're asked for this, find the slope, you only give the coefficient. And what happens here is students tend to, they'll solve for y perfectly, no problem, and then they'll leave it. and they'll never identify what the slope is. So you have to tell me what, what that is. All right, questions with that? Okay. Too far ahead here. Okay, we want to graph the line that passes through -1, 5 and has a slope of a -5/3. Alright, so here's our coordinate plane. And so first thing we're going to do is we're going to identify, first thing you want to do is you want to graph, step 1, plot your point. Okay, so here's x is -1, y is 1, 2, 3, 4, 5. So here's -1, 5. Plot that point. And now we're going, if the slope is negative, you're going to move down. In this case, because it's negative, we're going to move down 5 and right to the right 3. So the denominator, you're always going to move to the right. The sign will tell you whether you're going to move up or down. If it's positive, you move up. If it's negative, you move down. So we start at this point, and then we're going to move down 5. So that's going to be 1. We're going to go 1, 2, 3, 4, 5. And then across 3. 1, 2, 3. Okay, so we move down 5. And right 3. And then we just draw the line from there. Okay, so on MyMathLab, and I'll show you how to do that on here. You have to. There's a little palette down the bottom, and it has like a line, and it's got like a parabola. It moves up and down, and then to the side like that. It has like different lines here. Okay, you're going to select the linear equation, the line, and then you just click your first point, and then you go to your second point. You would go down 5 to the right 3. Click it again, and then there you have your line. Okay, so I'll show you. We'll go over that. All right, questions with that? All right. And so there it is. You start with -1, 5, and you go down 5 and right 3, and there's your point. Okay? A line with a positive slope rises from left to right. It goes up. It moves up. It rises up. A line with a negative slope will fall down from left to right. A line with a 0 slope goes through the x-axis. There's no slope. It does not move up. It does not move down. It's just 0. And it's just straight across. Okay, the slope gives the average rate of change. So when they ask to find the average rate of change, or they're given the average rate of change, look over here. The average rate of change is the slope. Okay? Average rate of change means the slope. Alright, so if you're given, here we have, in 1980, the average monthly rate for basic cable TV is $7.69. In 2008, the average monthly rate is $46.50. $46.13. Okay, assume a linear relationship. So basically what we have here is 1980, it's $7.69. That would be your X1, Y1. And then in 2008, let me do this over here. 2008, it's $46.13. Okay? Assume a linear relationship and find the average rate of change. So what are we looking for here?
Heavy rate.
The average rate, yeah, which is what?
Slow.
The slope, good. We're looking for the slope. So this would be x1, y1. This would be x2, y2. Given our slope, and it helps to write this down. y2 minus y1 over x2 minus x1. Okay? Alright. And so basically this is what they gave you for your points. Alright, we did them up here. So this would be y2 is 46.13 minus y1 is 7.69 over, what are we going to put for the denominator? It'd be what?
2008.
2008
1980.
minus 1980, right. Okay, so basically 4613 minus 769 is 38.44 over 28. Okay? And let's see. Assuming linear, let's see, monthly basic rate. I'm looking to see if they want this rounded off. Let's see it rounded off. So from there, okay, what they went ahead and rounded to the nearest hundred, 1.37. So if you look graphically, here's your monthly rate in dollars. Here's your $7.69. Here's your $40. Here's $40. Here's $50. So 46.13. You know, that's going to be a little bit more than halfway between 40 and 50. And you got 1980, and then here's 2005, 2010, so 2008 is a little bit past that, halfway between that. And so you see those 2 points, you see it on the graph. And so your average rate of change is $1.37 per year. $1.37 per year increase. Okay? Alright, questions with that? Okay, so let's see what that looks like. Let's just look real quick on MathXL. Or not MathXL, we use MyMathLab. Oh, no wonder. Alright. This is lesson 19. Okay, here we have graph the following linear function. Give the domain and range. So it says here, click the enlarged graph. Now you see this palette off to the right here? Oops. There we go. See this palette off to the right? You want to click the line because you're graphing a linear equation. Okay, so we click that. Now, and then your first point is -5. And so basically we're going to go up 1 and across 1. And there you go, you plot your second point. And then save it. Okay? Alright, questions with that? Alright, let's see if we can find another one. That's basically the same thing. F of x equals to -2x. So basically, this is like y equals to -2x, right? So we click this, click the enlarged graph, we click that. Let's see if we can do it from here. No, we have to click this box here first. And so we click that. And then we click the line because we're graphing a linear equation. And we're graphing f of x equals to -2x. So we're going to go through y at -2x. So you click one point, and then you go straight across, and you click another point, and there you go. And then you save it. Okay? And then save. Okay, well, we're in preview mode, so. Alright, questions with that? So later on, we're going to get into graphing absolute value and parabolas, and you've already done circles, so. And then here's also solid and dashed lines. We're not doing dashed lines right now. Alright, so let's see if there's anything else that's different. Looks like everything else, they're all the same. Alright? Questions with that? Yeah. Alright, they're all the same. Okay. Alright, any questions at all with that assignment? Alright, well, that is lesson 19, so we'll stop.